All right, everybody, we are going to start today's notes. They are called Equivalent Forms of Real Numbers, Part 2. This is page 6 from your math binder, and we're going to also go on to page 7 in your math binder as well. So you should have those two pages handy, pages 6 and 7, and we will get started at the top on number 1. On number 1, it says, a square patio has an area of 100 square feet. Write the side length of the patio in 2 different ways. So something that we should remember from the page of notes that Ms. McGowan did on the squares, we said that side length is always the square root of the area. I'm going to say that again. Side length is always the square root of the area. Side length is always the square root of the area. Side length is always the square root of the area. Side length is always the square root of the area. Side length is always the square root of the area. And just in case you forgot, side length is always the square root of the area. So I'm going to write something at the top of my paper. Wonder if you can guess what it is. At the top of my paper, I'm going to write side length is always the square root of the area. So why is that important? Well, let's look at number 1. Square patio has an area of 100 square feet. Write the side length of the patio in 2 different ways. So the area was 100, and I know that on these squares, the side length is always the square root of the area. So I'm going to say that my answer is the square root of that area, which was 100. Now this is asking about feet, so I'm going to say feet. Remember, when you find the area is squares inside, but the side length isn't squares along the edge of it. It's just like a ruler measurement. So we just say feet, no squared on that one. Okay, so why does it say in 2 different ways? Well, I need to calculate what the square root of 100 is. Many of you already know what that is off the top of your head because 100 is a perfect square. But let me type in 100 square root is 10. Okay, so when I go back to this, I can also say that this is 10 feet. Let's try number 2. A square patio has an area of 200 square feet. Write the side length of the patio in 2 different ways. So I'll start by knowing that side length is always the square root of the area. So my side length is the square root of this area, 200. And this was also feet. Then, now I can calculate what that would be. Square root 200, and look, it's a very long decimal. Now let's remember, when we round here, often I'll tell you what to round to, but sometimes I won't, but typically it's going to be tenths or hundredths. So I'm going to round this to the nearest hundredth. Remember, hundredth is 2 places past the decimal. So this has 1 4, and then I have to look at the piece after it. In the thousandths place, that's a 2, and that number is not large enough to bump up the tenths to a 5, or the hundredths to a 5. So we're going to keep this at 14.14 because that 2 does not round up for the 4. Okay, so I'm going to write down 14.14 for my other way to write that answer. Okay, so let's look at this next little section. We're going to estimate irrational numbers to the nearest hundredth. So here are the steps for how we do that. You're going to find 2 consecutive perfect squares that the number under the radical falls between. So perfect squares, let's make a list of them over here in the question/notes. I want you to write in over here, perfect squares. And we are going to make a little list here of all the perfect squares that we know so far. So what's a perfect square? Well, we talked about this back, we did that squares challenge, but I'll start with the first perfect square. The first perfect square is the product of 1 times 1 because I multiplied the same number by itself. So 1 squared gives us the perfect square 1 because 1 times 1 is 1. Okay, our next perfect square would come from the product of 2 times 2. 2 times 2 is 4. But I'm going to write that it's 2 squared. So my perfect square is 4. Okay, 3 squared, 3 times 3, gives us the perfect square of 9. 4 squared 4 times 4 gives us the perfect square of 16. 5 squared, 5 times 5 gives us the perfect square of 25. 6 squared is 6 times 6. That gives us the perfect square of 36. 7 squared, 7 times 7 gives us the perfect square of 49. 8 squared is 8 times 8. That gives us the perfect square of 64. 9 squared, that is 9 times 9, gives us the perfect square of 81. I ran out of space, but I'm going to keep going. 10 squared is the product of 10 times 10. That gives us the perfect square of 100. Let's go to 11 squared is the product of 11 times 11. Off the top of your head, that is 121. Okay, now there are more. We could do 12 squared, 144. And we could keep going on and on and on. I am actually going to stop at 12 squared. Not that that means that our perfect squares stop there, but it does mean that my list stops there because I kind of ran out of space and I'll just have to use my calculator to find the rest of them if I need to. But these are the perfect squares that we're going to see often. So I feel like it's gonna like fade when I do this. I'm just gonna take my highlighter across those. These are all of our perfect squares. So these are the numbers that I was talking about when I said, what two perfect squares does it fall between? Okay, so let's go back to number 3 here. 5 square root of 5 is an irrational number. But if I look at that number under the radical, it's a 5. What two consecutive perfect squares does 5 fall between? So look at this list. Is 5 between 1 and 4? No, but 5 is between 4 and 9. So I know the square root of 5 is going to fall between the square root of 4 and the square root of 9. Now we're going to go through a lot of process here, and I want you to check everything that I'm doing and follow along and write down everything. I know you might get lost somewhere in there. That's okay. That's why we're writing down notes. You're not an expert right now. Okay, so just write down everything I'm doing, even if it starts to get confusing. So I know that the square root of 5 is going to fall between the square root of 4 and the square root of 9 because 5 already sits between 4 and 9. So square rooting it would still keep it in the middle. Now take the square root of each of those numbers. So I do know what the square root of 4 is. I could type it in here, but that would be a little bit silly. Watch what happens. If I type in square root of 4, I get 2. Yeah, that's because 4 came from 2 times 2. That's what's so nice about these perfect squares. If one of these is under the square root, that means whatever had to be squared is the answer. So square root of 4, I'm gonna draw down here, is equal to 2. Square root of 9 is the product of 3 times 3 under there, so I've got a 3. And now I'm going to do a little bit of trial and error. So we are going to see what happens when, let me rephrase this. The number 5 is closer to 4 than it is to 9. So its square root is going to be closer to 2 than it is to 3. So I'm going to start with a number that's just barely above 2, and I'm going to try squaring it and see if I get 5. So I'm going to start with 2.1, and I am going to square that, and I get 4.41. So let me write that down on my paper. I'm going to say 2.1 squared equals 4.41. Now, 8th graders, that's not the square root of 5. Is it above it or below it? Well, 4.41 is lower than 5. So that means 2.1 was too low. So let's go a little bit higher than 2.1, and we're going to try 2.2 squared. So let me type in 2.2 squared, and I get 4.84. 8th graders, still too low, so I've got to go a little bit higher. Let's go with 4.3 squared. Why did I say 4.3? Oh my goodness. Let's go with 2.3. Do you like how I turned that into a 2? It looks like garbage. Okay, so 2.3 squared, 2.3 squared. Let's see if we got 5. Ah, it went too high. I've got 5.29. So 5.29, these were like the brink numbers. It has to be somewhere between those two. Remember, we're trying to find this to the nearest hundredth, and right now we're checking the tenths. So what does that mean? It means now we need to go between 2.2 and 2.3. How do we do that? Let's start by doing 2.25 squared. I know that that's halfway between the two of those things. So I'm going to type in 2.25 squared. And I get 5.0625. Okay, that number is still too high. So 2.25 is too large of a number to be the square root of 5. So let's go with 2.2, and I'm going to go lower than 2.25. I'm going to go 2.24. Let me type that in. 2.24 squared, and I get 5.0176. Okay, still too high. So I have to go lower than 2.24. Let's go with 2.23 squared. 2.23 squared. It went lower. Okay, so I've got 4.9729. Who wants to keep going? We know that it's between these two. We could then go and check 2.235, and if that was too high, we could change it again and again and again. We could keep going closer and closer and closer to the exact answer, which is actually what your calculator does when you just go back and type in square root of 5. But that's not what I'm asking you to do. I want you to know this process of how your calculator finds it so that you can appreciate where that number is coming from. So you don't just trust everything that comes out of a calculator, because sometimes you type in stuff totally wrong, and then your calculator, you trusted it. Like, how could it betray you? Because you type stuff in wrong sometimes. So I want you to have a very good understanding of why the square root of 5 falls between the numbers 2 and 3, and why it's a little bit closer to 2 than it is to 3. So we're gonna go with, let's see, which one's closest? 4.97 is pretty close to 5, but 5.01 is a little bit closer. If I ignore these last two digits here, this one's only 0.01 above 5, and this one is 0.03 below 5. So I'm going to go with this as my closest estimation. I'm going to say square root of 5, and then I'm going to use the approximate symbol. It's a squiggly equal sign, is approximately 2.24. Now the reason I stopped at hundredths is because I know how to read, and the directions said round to the nearest hundredth. Okay, I am guessing that at least 50% of you just feel like you got run over by a tidal wave. That was a lot of stuff that we did there, and a lot of like checking and guessing and back and forth with the calculator. So we're gonna do it one more time. Get your pencils ready, because let's jump into number 4. On number 4, square root of 52. Our directions say find 2 consecutive perfect squares that the number under the radical, that square root, falls between. So what is 52 between? Go back down to our list. 52 is between the numbers 49 and 64. So I'm going to write that down. It is between square root of 49 and square root of 64. And then if I find the actual square roots of these, I'll know what the answer is going to be between. 49 square root is 7. 64 square root is 8. All right, let's start calculating some stuff. Now, is 52 closer to 49, or is it closer to 64? It's a little bit closer to 49, but it's not like it's directly above it. If it was 50, we'd say like 7.1 for our first guess. I'm gonna go with 7.2 for my first try. We're gonna go 7.2 squared We'll go back to our calculator, 7.2 squared, and I got 51.84. Woo, that's close. 51.84. All right, so let's go up to 7.3 and we'll square it and see how we do. 7.3 squared. 53.29. 53.29. Okay, so it's going to be between these numbers because 51 was below 52, and this 53 number was above our 52. Oops, I accidentally wrote on my paper. So let's go with now 7.25, and we're going to square that and see how close we get. 7.25. Oh my goodness. Do you see how silly that was? I just typed in 7.25. I didn't even square it. There we go. I've got 52.56. I'm just going to say 56 instead of writing all that stuff down. So 52.56. That number is above 52. So I've got to go a little lower than 7.25. Let's go 7.24 squared. 7.24 squared. And I got 52.41. Whew, we're slowly moving down. That's still too high though. It's above 52. So I'm going to go 7.23 squared. 7.23 squared. And I got 52.27. Ah, still too high. So let's go with 7.22 squared. Hopefully this works because I'm running out of space. 7.22 squared. Spoiler, one of these is going to work. It always will have an answer. 52.12. Technically 0.13 if we're rounding properly. Okay, still too high. So I've got to go lower than 7.22. I should have started lower, just to be clear here. We're going to go 7.21. Fingers crossed that this is the place I want it to be. 7.21 squared. Ah, finally, we dropped below 52. So I'm going to write down 51.98. Okay, one of these is going to be our answer. So which one is closer to 52? Now this one here is 0.13 above 52, and this one, 0.98, is only 2/100ths below. So this one is going to be closer to the actual answer that we wanted. So I'm going to say the square root of 52 is approximately equal to 7.21. All right. Let's go to numbers 5 and 6. On these numbers, that's a really long process, and it's not really realistic to force you to do this every single time. I wanted you to know where this came from. I wanted you to try down a couple problems. But on these, we're actually going to do a little bit of estimating. I want you to look at this square root of 10, and I want you to look at this list. Where does it fall? It's after 9, but it's above or below 16. So you're going to make an estimate, and it better be somewhere between 3 and 4, because 9 and 16 are on the sides of 10. So we're going to write estimate, and you're going to estimate what you think it could be. Write down an estimate. Your estimate better be between the numbers 3 and 4. Now, if you're feeling really confused, so you just write down 3.5, that's not a great estimate, because you would be saying that 10 is halfway between 9 and 16. That doesn't make any sense. So 10 is really close to 9. That means your answer is going to be really close to 3. So you might want to guess something closer to like lower 3s. I'll give you a second to write down an estimate. I'm going to make an estimate of, I don't know, let's say that my estimate is 3.19. I don't know. I felt like I had to put a 9 on there. So now underneath that, we're going to go actual. We're going to figure out what it actually is by typing it in our calculator. So come over here, let's type in square root of 10. I was really close. Instead of 3.19, which was my estimate, it's actually 3.16. So the actual is 3.16. I'm like so anxious if some of you might have actually guessed it correctly. Good job. Some of you might have cheated and just typed it in and figured out the answer and then pretended like that was your estimate. I actually don't care if your estimate was correct. This is just to give you a little bit of like stretching of these muscles to see if you can figure out where an estimate could be if you were ever in a place in your life where you didn't have a calculator on hand. So 34 square root. Find where the perfect square would fall in this lineup. Now I know 34 is between the numbers 25 and 36. Which one is it closer to? 36 for sure. It's just a little bit below 36. So that means my answer is going to be just a little bit below 6. Let's go with, I don't know, let's do our estimate. Write down your estimate. Hopefully yours is better than mine. I'm going to go slightly below 6. So it's going to be 5.87. I'm not looking at the answers, by the way. I chose 5.87 because it's close to 6. It's almost to 6 if you were on a number line. On your number line, 5 and 6 would look like this. And 3.8 or 5.87 would be like there. So I know that 34 was just a little bit below 36. So its square root is hopefully going to be just a little bit below 6. Okay, let's find our actual. We're going to go back to our calculator, and I'm going to type in the square root of 34. Darn. Still close though. 5.83. Not a bad guess, Mrs. Johnson. I hope some of you got it correct. If you did, you should definitely tell me in the comments of today's submission. So, or tell Miss McGowan or Mr. Bodley, because like obviously you're awesome and we want to know that. By the way, when I was talking, I forgot the answer. 5.83. Close. All right, let's go to problem number 7. On problem 7, 20 pi, okay, we panicked and now we're done panicking. 20 pi is not a square root. So what do we know about pi? It's about 3.14, right? A little bit above 3. So if I'm estimating right now, I want to just pretend like pi is close to 3. So if I were to count 20 times 3, that'd be 20, 40, 60. So if it's really 3.14, it's going to be a little bit above 60. So like 60.5. I'll put that down. 60.51. I'm not great at mental math. If like Mr. Bodley was up here, he'd probably know the answer for reals, or Miss McGowan. Mrs. Johnson, not a human calculator. Okay, let's find the actual. I really hope I was kind of close because now I feel a little bit embarrassed if it's totally off. We're doing 20 pi. What does it mean when it says 20 pi? Well, you're actually doing 20 times pi. When things are right by each other like that, where's pi? Let me look. ABC, no. Function, yes. You have to click the function tab. So when I click the function tab, I can then put pi on here. Was I close? I mean, not super close, but I was close-ish. So again, I found pi by going to function. It was in the bottom right corner. And my answer is 62 point approximately 83. So let me write that down for the action. Wait, 62. Yeah, oh gosh, Miss Johnson was very off. Okay, 62.83. See, I told you, my mental math skills, not great. Actually, story time in elementary school, whenever we had to estimate, I had such a hard time because I just like second guess it like 100 times in my own head. And sometimes I would like actually figure it out the longhand way, and then I'd make my estimate slightly different. Not that I'm trying to give you skills to fake estimate. It's actually a really good life skill to be able to estimate properly. So that's why we're practicing it. Okay, square root of 105. We're back to radicals with square roots. Let's go to our list of perfect squares. Where does 105 fall? It's between 100 and 121. That means my answer is going to be between 10 and 11, but probably a lot closer to 10 because 105 105 is a lot closer to 100 than it is to 121. So I'm going to go with like 10.19. That's my estimate. 10.19. Okay, let's go for actual now. We're doing square root of 105. Square root 105. 10.24. Ladies and gentlemen, that was pretty darn close. Actually, if we round this correctly, that should not be 10.24. It should be 10.25 because the 6 after the 4 would force the 4 to round to a 5. So let me write down 10.25. All right, so we've got our estimate and we've got our actual for number 8. You're fine to come in, Sam. Now let's go to problems 9, 10, and 11. We're going to plot these numbers on the number line, and it says with only 2 scale markings. So what the heck does that mean? And how do I put this on a number line? 3 pi, where would that go on a number line? It's not going to go where 3 would go on a number line because you're actually multiplying 3 times pi. So let's start by putting a little note on the side here. What I want you to remember is that when you have an irrational number or a radical or a fraction even, I want you to compare those numbers by converting back to decimals. Decimals are going to be the common denominator between all of these things because decimals carry through, and you can do a decimal approximation for any irrational number, and you can do a decimal approximation for even rational numbers, especially if they've got repeating decimals or something like that. So I'm going to zoom out quick. We're going to twist our paper sideways, and I'm going to write something very large on the side of my paper. When comparing numbers, convert to decimals. When comparing numbers, convert to decimals. When you're comparing numbers, convert to decimals. When you're comparing numbers, convert to decimals. And in case you forgot, when you're comparing numbers, convert back to decimals. That's how you can compare two things, especially if they're different. And there's stuff like that in tonight's homework. So on this one, we're just trying to find where a number goes on the number line. So 3 pi, I'm going to draw a little arrow here because I'm going to convert it to a decimal. So go back to our calculator, 3 times, and remember pi is under the function tab, pi, 9.42. And that 4 does not make it round up to a 3, it stays 9.42. So I'm going to go back to my paper and I'm going to write down my decimal approximation, 9.42. All right, the number 9, where does that go on a number line? Or, sorry, the number 9, we know where that goes. But the number 9.42, where does that go? Well, it's going to be between the numbers 9 and 10. 9.42, that's a little less than halfway. So I'm going to put a dot a little less than halfway on this number line. And then I'm going to go back to what the original irrational number was. And I'm going to put, that's where 3 pi goes. Because if I were to tell you that I was 3 pi years old, that doesn't make sense, but 9.42, that means I'm about 9.5 years old. And looking at a number line, I can see, oh, that weird kid who said he was 3 pi, he's a little over 9, which makes sense because 9-year-olds are kind of weird. All right, let's go to the next one. -5/4. If I asked you to put that on a number line, you'd probably be able to figure it out if you thought about it for a second. But some of you would be like, -5/4, that doesn't mean anything in my head. So let's convert it to a decimal. -5/4. And remember, to put a fraction in, it's always division. Top divided by the bottom. So you'll notice that the decimal that I got is -1.25. So I'll go back here, and I know that converted, this is -1.25. So what two numbers does this fall between? I am going to show you a very, very, very common mistake. It's my favorite mistake on this assignment, in fact. I often see people who put their number line like this, -1, -2, and then they put the -1.25. Well, that's pretty close to -1, right? So here's halfway, here's the 2.5. And they'll do it like this. Very close, but this is actually wrong, because that's not what negative numbers look like on the number line. Don't cross that out, because I'm gonna have to erase all that. Negative numbers on a number line. Let's remind ourselves what that looks like. Over here, I'm going to draw a number line. I'm gonna put arrows on it, and I'm gonna put 0 in the middle. Now I know that the number directly after 0 is 1, 2, and then 3. Now, if this were true, the number line that I just drew, that would mean underneath 0, there'd be a -2, then a -1, then Lord knows what. That's not how negatives work, remember? So on a number line, when you're going positive, it goes toward the right. But when you're going negative, that's pointing toward the left. So directly below 0 is going to be -1. And directly below -1 would be -2. Directly below that is -3. So do you see what's wrong with my number line? I put -1 on the left side, but -1 belongs on the right side of -2. So let's get our eraser of shame. We're just gonna erase all this stuff and we'll go back and fix it, because that's why we work in pencil. Just kidding, I'm definitely using pens right now, but I don't actually know. I have a whiteout pen. Oh, one of these lovely things. You'll see this debut in some of my videos. If you're using pen, hopefully you've got some whiteout on you. Not on you, but like in your possession. Okay, so -1 is further to the right. -2 goes toward the left, because that's how negative numbers work. Sometimes I try to remember, like, where's 0? 0 is going to be over here somewhere, right? So it goes toward the left from 0. So -1.25, here's halfway, that'd be -1.5. I go half of halfway, and that would be right about here. And I'm not going to write -1.25. I'm going to write the original thing they asked me to plot, which was -5/4. Okay, let's go to negative square root of 20. Now, if you're worried for a second thinking, oh no, is Miss Johnson trying to trick us? I can't take the square root of a negative, because if you go over here and you type in square root, oh, here we go, square root of -20, remember it tells you undefined. So let's look back at the problem. The square root is not, the negative is not inside the square root, so don't put it there. The negative belongs outside the square root. So let me fix this thing. Negative square root of 20. And I get -4.47 approximately. So my decimal approximation, because I'm always converting to decimals here, I already forgot. -4.47. Remember, negative numbers work backwards. So if 0 were over here, the two numbers around this are going to be 3 and 4. Technically -3 and -4. But the lower number, the lower digit, it works backwards. So -3 is going to be on the right. -4 is going to be on the left. I already made a mistake. Ugh, I get to put this thing in action. Do you see what I did wrong here? I said that -4.47 would fall between -3 and -4. That's not true. -4.47 would go further to the left. If it was on this number line, it would go past -4. So the -3 is totally unnecessary here. My number would be like here, and I need to put a -5 on this number line. So you'll watch my lovely erasing skills. There we go. It's like it never happened. Let's slide our number line a little bit and put it like this. Okay, now -4.47 is pretty close to halfway, which would be -4.45. So I'm going to put it a little less than halfway, and I will mark it square root of 20, because that's where the decimal came from originally. Okay, let's go to our last problem. Your friend says that the square root of 83 is greater than the 29/3. Is she correct? And how do you know? I want you to push pause, find these decimal approximations, and decide, is your friend correct or are they wrong? Push pause. All right, hopefully you started your video back up. Let's talk about what this answer would be. I'm going to approximate both of these so I can compare them and see which one's larger. So I'm going to go square root of 83, and I get 9.11. So I'm going to say this one is approximately 9.11. And then I'm going to approximate what 29/3 is. And remember, fractions are division. 29 divided by 3 gives me 9.666666667. So that is 9.6 repeating. Was your friend correct? Was this one greater? No, it wasn't. 9.6 repeating is definitely bigger than 9.11. If we compare them to nearest hundredth, 9.11 compared to 9.66, or if you round 9.67, 9.67 is going to be the bigger one. So is she correct? No. How do you know? Well, we have our decimal approximations, but let's put a number line on here so we can kind of prove how we know. I'm going to put 9 on this number line, and I'm going to put 10 on this number line. Now, if I were to put where 9.11 is, it's going to be just barely past 9. It's going to be somewhere like here. So I'm going to mark that square root of 83, because that's a little bit past 9. It's 9.11 approximately. And then 9.6 repeating is going to be a little bit past halfway, and that's our 29/3. Sorry, friend, you're wrong. How do you know? Well, the picture. Okay, I love explanations that have a diagram. Okay, we are done with today's notes. Do a little bit of practice, and I will see you the next time. Let me pause it.